Hello, everyone. In this video, we will discuss differentiation rules and strategies. Basic derivatives. Let k and n be real numbers and f be a differentiable function of x. Constant rule. The derivative of a constant k is 0. The constant rule is true whether the constant is a rational number, an irrational number, or a function of a real number. Power rule. The derivative of a variable x raised to n with respect to x is n multiplied by x to the power of n minus 1. That is, bring the exponent down as a constant multiplier and subtract 1 from the exponent. The following are some commonly used derivatives from the power rule. If n equals 1, the derivative of x with respect to x is equal to 1. If n equals negative 1, the derivative of x raised to negative 1, or the derivative of 1 over x, with respect to x, is equal to negative 1 over x squared. If n equals 1/2, the derivative of x raised to 1/2, or the derivative of the square root of x, with respect to x, is equal to 1 all over 2 times the square root of x. In summary, the power rule holds for any real number exponent. Constant multiple rule. The derivative with respect to x of a constant k multiplied by a function f of x is equal to k multiplied by the derivative of f of x with respect to x. That is, a constant multiplier can be taken outside a differentiation. The following are commonly used derivatives based on this rule. If f of x equals x, the derivative of kx with respect to x is equal to k. If f of x equals x squared, the derivative of kx squared with respect to x is equal to 2kx. The constant multiple rule is only applicable to a product of a real number and a function of the independent variable. For addition, subtraction, multiplication, and division involving two or more functions, please use the sum or difference, the product, and the quotient rules, which are discussed later in this video. Absolute value. The derivative of the absolute value of x with respect to x is x divided by the absolute value of x, provided x is not equal to 0. The following are a couple of definitions involving absolute values. First, the absolute value function. If x is non-negative, the absolute value of x is x. In other words, the absolute value of a non-negative number is itself. If x is negative, the absolute value of x is negative x. In other words, the absolute value of a negative number is the negative of that number, or simply stated, the number becomes positive. Second, the square of the absolute value of x is equal to the square of x. Derivatives of sums or differences, products, and quotients. Let f and g be both differentiable functions of x. Sum or difference rule. The derivative of a sum or difference is the sum or difference of the derivatives. In other words, the derivative is distributive over addition and subtraction. A general strategy here is to differentiate each term of a sum or difference. For a product or a quotient, convert to a sum or difference, if possible or if it makes the next step easier, and then proceed with using the sum or difference rule. Product rule. The derivative of the product of f and g is the sum of the products of a function and the derivative of the other function. Based on this rule, the derivative of a product can be found by: first, writing a sum of two terms where each term is the product of the two functions or factors. Second, getting the derivative of the first factor in the first term and the derivative of the second factor in the second term. Similarly, the product rule for two functions or factors can also be written as: for three functions, the product rule is given by: in the first term, the derivative of the first factor is taken. In the second term, the derivative of the second factor is taken. And in the third term, the derivative of the third factor is taken. Quotient rule. The derivative of the quotient of f and g is derivative of f multiplied by g minus f multiplied by the derivative of g all over g squared. Based on this rule, the derivative of a quotient can be found by: first, writing a difference of two terms where each term is the product of the numerator and the denominator. Second, getting the derivative of the numerator in the first term and the derivative of the denominator in the second term. Third, dividing by the square of the denominator. Similarly, the quotient rule can be written as: take note of the subtraction operation and the square of a factor. However, it is important to note that the derivative of a quotient is not the quotient of the derivatives. Strategy in finding derivatives. First, rewrite the function. Use strategies such as applying properties of exponents, radicals, and fractions, factoring and dividing out common factors, distribution of a factor by multiplication or division, and multiplying and dividing polynomials. Second, differentiate the function with respect to the independent variable. Apply differentiation rules such as sum or difference rule, product rule and quotient rule in order to transform a complicated derivative into simpler derivatives. Then apply basic derivative rules to complete the differentiation process. For composite functions that are not covered by basic derivative rules, apply the chain rule, which will be discussed in more detail in a future presentation. Third, simplify the derivative. Use properties of exponents, radicals, and fractions to rewrite and/or simplify the derivative. If possible, factor polynomials, divide out the common factors, and simplify the rational expression. Before differentiating, first, rewrite the function such that it fits any differentiation rules. Applying properties of exponents, radicals, and fractions. Use these properties to rewrite a function to be differentiated so that it fits a differentiation rule. Examples. Subtract exponents for quotient of the same base, while add exponents for products of the same base. A radical can be decomposed into a product of radicals. A complex rational expression can be reduced into a simpler rational expression by flipping the denominator and multiplying the result with the numerator. Factoring and dividing out. Factor both the numerator and the denominator and divide out common factors. Example. If possible, factor the numerator and denominator completely, and then divide out the common factors between the numerator and the denominator. Distribution. Multiplication and division involving a polynomial and a monomial. Decompose a complicated product or quotient into a sum of terms. Multiplication. Distribute the monomial by multiplying it with each term of the polynomial. Division. Distribute the monomial by dividing each term of the polynomial by this monomial. Multiplying and dividing polynomials. Involve two polynomials. Multiplication. Multiply two polynomials by multiplying each term of the first polynomial to every term of the second polynomial. Then, get the sum of all these products. Division. When the degree of the numerator is greater than the degree of the denominator, divide two polynomials by performing long division method. These techniques can be tedious. Proceed to differentiation immediately if the function cannot be made simpler by these methods. Second, differentiate using differentiation rules as a guide. Sum or difference rule. Apply the sum or difference rule to sum or difference of terms. Distribute the derivative over sum or difference. Product and quotient rules. Apply the product or quotient rule when the product or quotient cannot be further simplified, or when differentiating directly is easier than expanding the product or the quotient before differentiating. Basic derivative rules. After applying sum or difference, product, and quotient rules, use the following differentiation rules to complete the differentiation process. Constant rule. Power rule. Constant multiple rule. Absolute value rule. Use the chain rule for composite functions. Generally, the derivative of a composite function is equal to the derivative of the outer function times the derivative of the inner function. The following examples show when to apply a basic differentiation rule and the corresponding chain rule. The power rule for x raised to a real number n is n times x raised to n minus 1. As an example, the derivative of x squared with respect to x is equal to 2x. Meanwhile, the power rule for a function of x raised to a real number n is n times the function of x raised to n minus 1, multiplied by the derivative of the function with respect to x. As an example, the derivative of the square of quantity 3x minus 1 is equal to 6 times the quantity 3x minus 1. The chain rule is an advanced topic in differentiation, and it is discussed in another video. After differentiating, third, simplify the derivative. The following are some of the guidelines that can be applied to simplify the derivative. Factoring out a common factor. Examples. Factor out the variable with the lowest exponent. Subtract this exponent from the exponent of the same variable of each term. This is the equivalent of dividing each term by the common factor. And then, simplify the result. Aside from factoring the variable with the lowest exponent, the constant multiplier with the lowest magnitude can also be factored out. Divide each term by the product of the constant multiplier and the variable to be factored out. This is the equivalent of dividing each term by the product of the constant multiplier and the variable to be factored out. And then, simplify the result. Simplifying rational expressions. Examples. A rational expression can be simplified by combining like terms within the numerator or the denominator. And then factoring out common factors that can be divided out. A rational expression can also be simplified by combining multiple rational expressions into a single rational expression using the least common denominator method. To verify if the combined rational expression is correct, divide each term of the numerator by the least common denominator. It should return to the original rational expressions. And then, combine like terms. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.